Good morning and welcome back to Algebra 2. Today we are going to be talking about inverses of our quadratic and cubic functions. So quick review of what an inverse is. If I have two functions f and g, where if I take the composition f of g and the composition g of f, my outcome for both of those is x when they are inverses. Essentially they undo each other. And so if those are inverses of each other, our function notation for that is f to the negative 1 power. So today we are going to be finding inverses and verifying whether or not functions are inverses of each other. We did this earlier in the year, but you have slept a couple times since then. So first, let's review how do you find the inverse of a function. The first step is that if your function is given to you in function notation, we're going to replace f of x with y. Then we are going to interchange x and y. So anywhere there was a y previously, it's going to become x, and anywhere there was an x previously, it will become y. Then we're going to solve for y, so use algebra and order of operation rules to rearrange the equation. Once I have solved it for y equals, I am going to do step 4, which is rename it as f to the negative 1, so that function notation to indicate that it is my inverse. And then we're going to use composition to verify that they're inverses of each other. So let's jump into example 1, part A here to do those steps. So again, first step, rewrite it in y equals form. Then I am going to switch x and y. And then step 3, I'm going to solve this new equation for y to get y by itself. So the first thing I need to do is add that 2. And then to undo the square, I'm going to take the square root of both sides. And I have now solved for y, which means I'm ready to do step 4, which is put it in function notation. So f to the negative 1 of x is the square root of x plus 2. And I could do composition both ways to verify that I have found the correct inverse. Let's do this again on b. This is already in y equals form, so I don't need to do step 1. I'm ready to jump to step 2, which is switch my x's and my y's. And I want to get y by itself. So the first thing I'm going to do is divide both sides by 3. Then I want to undo the square root, so I'm going to square both sides. And then lastly, I'm going to subtract the 2. I now have y by itself, so I'm ready to do, I guess that was step 3. So step 4 is to put it back in function notation. So I've got x over 3 squared minus 2 is my inverse. Now, let's look at these. On A, I started with a quadratic and my inverse was a square root. On B, I started with a square root and my inverse was a quadratic. So, what this means is a quadratic and a square root are inverses of each other. So if you are finding the inverse or verifying inverses, you need to make sure that you have a quadratic and a square root in order for them to be possibly correct. All right, let's do this again on C and D. Following those same steps, on C, first thing I need to do, y equals. Step 2, switch our x's and our y's. Step 3, rearrange for x. So I'm going to divide by 3. And then to get rid of that y cubed, I'm going to take the cube root of both sides. And now I have y by itself, so I can put this in my function notation. So my inverse is the cube root of x over 3. Let's do this again for D. Again, this is already in the y equals form. So I'm ready to switch my x's and my y's. Use order of operations. I'm going to subtract 4. Now to undo the cube root, I have to cube both sides. And then I'm going to divide by 2. And there is my final function. So let's put it back in our function notation. F negative 1 of x is x minus 4 cubed over 2. Now let's look at C and D. For C, I started with a cubic and I ended with a cube root. On D, I started with a cube root and ended with a cubic. So cubic and cube roots are inverses of each other. So just like with our quadratic and square roots, if I am taking an inverse of one of those, I should end up with the other. Okay, so that's finding the inverse. The next thing we're going to do is practice verifying whether or not I have inverses. So remember, they undo each other. So if I do composition both ways, my end result should just be x. So if I have two functions, f and f to the negative 1, first I'm going to plug f to the negative 1 into f, and my outcome should be x. And I have to plug f into the inverse and get x as a result. You have to verify both of these in order to confidently confirm, yes, they are inverses. Now, if you do the first one and you don't get x, you can say, nope, not an inverse, and end it there. But if you are going to confirm, yes, it is an inverse, you need to do both compositions. So let's do this starting with a. I have two functions, 2 cube root of x and x cubed over 8. Now, I already know that a cube root should give me a cubic inverse, and I do have that here, so now let's use composition to verify. Let's do f of g first, and so what that means is I'm going to take this entire function of g and substitute it for x inside of our f function. So that's going to be 2 times the cube root of x cubed over 8. Now I need to simplify. Well, x cubed over 8 is a perfect cube. The cube root of x to the third is x. The cube root of 8 is 2. So that's going to become x over 2. 2 times x over 2 is going to be 2x divided by 2, and that simplifies to x. So it worked the first way. Now I have to verify it the other way. I have to do g of, f of x. And so this time I'm going to be plugging in my entire f function in place of in place of x in our g function. So that's going to be 2 cube root of x cubed over 8. So to cube this, I have to cube both the 2 and the cube root of x. So that's going to be 8 times x over 8, which does reduce to x. So the composition worked both ways. So yes, they are inverses. Okay, let's go again and look at b. I have f and g. F is a quadratic and g is a square root, so they could be inverses of each other, but I need to use composition to confirm. So let's go with f of g first. So what this means I'm going to do is I'm going to plug in this whole function of g into x in my upper function. So it's going to be 4 times the square root of x over 4 plus 6 squared minus 6. Now I'm squaring a binomial, which means I have to FOIL. And when I FOIL this, what I'm going to end up with is a trinomial. So let's show first just the work for the FOILing here. So that's square root of x over 4 plus 6 times square root of x over 4 plus 6. When I multiply the roots together, that's going to give me x over 4. Then I'm going to get 6 times square root of x over 4, 6 times square root of x over 4, and 36. So I can combine the middle terms. And here is my result from FOILing. So this is going to go replace this. We squared that, so we can do our next operation. And my next operation is going to be to distribute this 4. So that's going to leave me with x plus 48 times the square root of x over 4 plus 144. And the last thing that I can do to simplify is this subtraction here. So this is completely simplified now. And my result is not x, so I don't even need to do the second set of composition because I know the first one did not work out. So these are not inverses. All right, last one on C, I have f and g, and f is a cube root and g is a quadratic. So I can already identify without trying to do composition that these are not going to be inverses of each other. And that is because a cube root has a cubic inverse. So I already know that these will not be inverses of each other. And that wraps up today's notes.